Beneath the quiet surface of a forest, a relentless, mechanical struggle is underway. Vines actively choke out the competition, while roots lock in silent turf wars for every inch of soil. This is a highly complex biological machine, one that never stops competing. Some of these engines, like the temperate deciduous forests of the Northern Hemisphere, are built to endure brutal, cyclical extremes. Others, like the neotropical rainforests near the equator, operate under permanent, stifling stability. This creates two entirely different survival economies. In the north, life must withstand freezing, deadly scarcity. Near the equator, life has to navigate relentless, wet hyper-competition. Making it in either environment requires more than physical endurance. To survive, the plants and animals living here have to figure out how to outsmart the mechanics of their own ecosystem. In the temperate forest, winter operates like a complete system shutdown. The temperature drops, snow covers the ground, and survival becomes a desperate waiting game against freezing conditions. Animals trapped in this seasonal freeze have to stretch their energy reserves to the absolute limit. The European bison, heavily insulated by its thick fur, resorts to digging through the snow to find old roots and tearing bark off dormant trees, just to keep its internal engine running. When the ice finally breaks, the starvation of winter triggers an explosive sprint. The trees have a very narrow window to capture energy, so they deploy massive, broad leaves that violently unfurl. These act as high-capacity solar panels, soaking up as much light as possible in record time. To fuel this massive burst of springtime growth, the trees tap into raw energy they hoarded deep inside their roots and heavy trunks during the long winter sleep. This intense energy cycle powers a highly specialized food web. As older trees die, wood-eating beetles move in to harvest the remaining nutrients, which in turn feeds the local woodpeckers, like the elusive black woodpecker, who drill into the decaying trunks to reach the larvae. The entire ecosystem operates on a strict timer. Every ounce of energy collected during the frantic summer months is hoarded and stored, preparing for the inevitable return of the cold. When the days shorten, the forest initiates a precise shutdown sequence. Trees deliberately cut off the nutrient supply to their own leaves, causing the green chlorophyll that powered their summer growth to slowly fade away. With the green gone, the underlying red and brown pigments are finally exposed. That chemical reveal is what creates the iconic seasonal color shift. Millions of dead leaves then plummet to the forest floor. This heavy blanket of debris creates a rich, fertile layer for fungi and microbes, which slowly break down the organic matter to prepare the soil for the next growing season. This seasonal shutdown secures the forest's future. By shedding their leaves and recycling nutrients into the soil, trees execute a vital, long-term investment that ensures the entire system survives until the spring return. This dashboard tracks the exact metrics required to build a true rainforest. To qualify, an environment must maintain a narrow temperature range of 27 to 30 degrees Celsius, lock in 80% humidity, and absorb at least 1,700 millimeters of rain every single year. Because these parameters never drop to a freezing point, there is no winter die-off to reset the system. As a result, the population density explodes, with 90% of the region's biodiversity locked in a permanent year-round fight for space. In an environment where food and water are everywhere, the competition is fierce. To survive the crush of thousands of other species, life must move beyond general survival and carve out an incredibly specific, narrow niche. Take the northern tamandua. It has a very strict business model. It can eat up to 9,000 ants a day, but it actively rations its attacks, never fully wiping out a single colony. It grazes just enough to survive, ensuring the insect population recovers to provide a steady food source for the future. The spider monkey relies on heavy mental processing to navigate the competition. Finding scattered, ripe fruit in an endless sea of green requires exceptional memory. Their ability to map and recall specific fruit trees across huge swaths of jungle makes them one of the most intelligent primates on the planet, trailing only orangutans and chimpanzees. In a biome that never hits the pause button, life adapts through extreme intelligence and highly specialized behavior rather than retreating into hibernation. Whether driven by the ticking clock of winter or the endless deluge of tropical rain, both systems have engineered a flawless internal balance. The byproduct of one creature always serves as the critical foundation for another. Massive industrial-scale logging has disrupted this ancient perfection. These activities have made temperate forests some of the most heavily altered landscapes on Earth. The math in the neotropics is even more precarious. Tropical rainforests hold more than half of all species on Earth, yet they have been reduced to covering less than 6%